Raymarcher provides the capability to convert or render regular meshes into volume data, specifically into 3D texture. There are 3 different ways to achieve this. The first one is the mesh printer. Mesh printer prints the vertices of target mesh instantly or progressively into a volume box. Mesh slice renderer renders target meshes with a slice shader and packs the rendered slices into a 3D texture. Perspective-driven volume renderer renders targets from 3 different perspectives. I've already talked about this in the previous video while I was talking about the perspective-driven volume box. In this video, I will talk about mesh printer and the mesh slice renderer. Each option has its advantages and disadvantages in terms of precision and data storage. You can create mono objects for each converter or renderer via GameObject, Raymarcher, Toolkit. The mesh printer is likely the most effective way to convert regular meshes into volumes in the Raymarcher. It prints the mesh vertices directly into a 3D texture. However, one drawback is that it tracks mesh vertices only, so if the target meshes are low poly, it might be noticeable that the printer creates points on those vertices, resulting in a less detailed model. Additionally, this component is not compatible with mobiles and WebGL, as it utilizes compute shaders and consumes a significant amount of GPU resources. The advantage is that you can print any high poly mesh, and you can observe the print process. After creating the component via hierarchy create, assign the target fixed 3D volume box. You can assign the root into the getChilds from root field of all the meshes you would like to print, or you can assign individual meshes into the target mesh filters field. You need to define the volume resolution, and you can set the initial volume canvas that will be included in every print process. The higher the volume resolution, the more memory it consumes, but the more detailed your 3D texture will be. There are 2 print modes: Instant, which prints the mesh instantly, and Progressive, which prints the mesh progressively every frame, and there is an option to travel from vertex to vertex over a specific duration. Once your print canvas already exists, you can print as new or as additive to add the new volume data to the existing 3D render texture. Play around with the brush parameters for the best results. Afterward, you can release the results or save the printed 3D canvas. Once you have saved the created 3D texture, you can use it further in the text 3D volume box and modify it at runtime using Voxel Painter, which I will talk about later. Speaking of materials, I can now demonstrate how to use the Material Compositor modifier. Select the target text 3D volume box and add a material compositor modifier. You can assign up to 4 material instances of the same type. You can't enter a different type of material. I'm going to create 4 material instances of a slope type. Each will have a different texture and functionality. If the material compositor is set, select the Mesh Printer tool and assign the existing modifier to the material compositor field. Now, as I have my existing 3D texture, I can use it as an initial canvas and draw additionally into that. I would like to now draw a material that is on index 2. I can check the index in the material preview list on the main renderer. Now you can see that I'm printing the voxels into the texture using the material index. You can see that the slope material interestingly creates a natural landscape. Again, I can save the working canvas into 3D texture and use it later. For instance, I can right away assign the 3D texture to my volume box, create a volume character controller, and explore the world from a first-person camera at runtime. How simple is that? With the Mesh Printer, you can easily create a simple voxel art in a smaller scale at runtime or in the Unity editor. The Mesh Slice renderer converts sliced meshes into 3D texture. It is the least precise technique as it renders the white pixels of the current slice progress. The major disadvantage is that the meshes whose faces are aligned perpendicularly towards the rendering camera won't be captured. Additionally, this component only works in the Unity editor. The advantage here is that it's not dependent on a vertex count, but you need to properly align the mesh faces so they are always visible to the rendering camera. After creating the component, assign the target slice material. create a new material and assign the required shader. Assign this material to all the meshes you want to convert to volume and place them within the camera's defined bounding box. You can preview the slice progress right in the editor, adjust mesh vertices to the camera's view and change the slice width. It's highly recommended to use the common volume resolution so that you can easily get the output 3D texture to the voxel painter and modify the texture at runtime. Custom resolutions for voxel modification are not supported. Once you render the sliced mesh, save it to the assets and preview the 3D texture. Now I can use that 3D texture in my volume box. That was everything about the Raymarcher mesh to volume converters. Thanks for watching and good luck.